topic of this video is looking at physical properties, alcohols, ethers, alkyl halides, and thiols. And physical properties, remember, are based on the strength of the type of intermolecular forces experienced by the molecules in question. And it's been mentioned quite a bit in this chemistry sequence, but you have hydrogen bonding, that's the strongest intermolecular force experienced by covalent compounds. And you have dipole-dipole, and then you have London or dispersion forces. I'm just going to say London forces. It's the weakest. So if we draw three comparable alcohols, ethers, alkyl halides, and thiols. So we've got three carbons. Of these four, again, I'm making a comparison because they're similar in size, because they've got the same number of carbon atoms. Only alcohols can hydrogen bond. Therefore, they will have the highest melting point and boiling point among those four classes of compounds. Okay, remember, hydrogen bonding is the strongest intermolecular force that has to be broken in order for the molecule to boil or melt, just depending on what the physical or the state of matter is at room temperature or a given temperature. But because they can hydrogen bond, they're going to have the highest boiling point of those four. Ethers and the other two, they can't hydrogen bond. Okay. None of them can hydrogen bond. The three that's remaining: ethers, thiols, and alkyl halides. Okay, so they're going to be less than alcohols. Now, but they all do show dipole interactions. Okay, so predicting their physical properties, like does an ether have a higher melting point or boiling point than a thiol versus a bromine, that's a little bit harder to predict based on what you know, but in general, sulfur and most halides, exception being fluorine, but fluorine can hydrogen bond. Remember, sulfur and most halides are heavier than oxygen if you look at the periodic table. Okay. Therefore, they have a tendency to have higher melting points and boiling points compared to ethers. Okay. Bromine is a very heavy atom. Chlorine is twice as heavy as oxygen is if you look back at the periodic table. Sulfur is exactly twice as heavy as oxygen. It's got a molar mass of around 32 grams per mole versus oxygen 16. So they're heavier. That would give them stronger London forces as well. So of the four, alcohols will have the highest melting points and boiling points because they can hydrogen bond. And then thiols and alkyl halides. And then last are going to be ethers as far as the physical properties go. Solubility in water. The rule is such that for alcohols, covered this before, in general solubility, if you have one hydroxyl per 5 or fewer carbons, that ratio, they generally dissolve in water because they can hydrogen bond with water. The hydroxyl group is capable of hydrogen bonding. So that ratio of 5 to 1. Alkyl halides and thiols in general have a low solubility in water. Low to none. And why? Because they can't hydrogen bond. So in general, even though they have dipole-dipole interactions, no hydrogen bonding with water, they generally will not mix with water. And only small ethers have a little solubility in water. But in general, again, because they can't hydrogen bond, ethers aren't soluble in water. Because of hydrogen bonding. They're more lipid soluble or fat soluble because they can't hydrogen bond. So in review, alcohols can hydrogen bond with water and they can hydrogen bond in general. So they have the strongest physical properties of those four categorically. Thiols and alkyl halides have a tendency to have higher melting points and boiling points compared to ethers because the high molar mass of halogens and sulfur. And ethers, alkyl halides, and thiols do not dissolve in water very well at all, again, because they cannot hydrogen bond. And that's a brief discussion of the physical properties of alcohols, ethers, alkyl halides, and thiols.